Hello guys, welcome back. So in this video we are going to discuss about power transformer and feeder downstream feeder protection. Okay, so let's start with this flow chart. So power transformer protection is mainly divided into main protection, backup protection and thermal protection. Okay, so we'll start with the main protection. In main protection we have differential protection that covers the area between HVCT to LVCT, and it works on the differential principle. All right. And also for HV winding we have REF protection, restricted earth fault protection, and then we have mechanical protection for incipient fault or slowly developing faults. um, that is the gases developed gases or the pressure is developed in the oil. That principle we use for the Buchholz relay and for the PRV. Then we have the second and fifth harmonic blocking. We need to block the second and fifth harmonic while the transformer starting. Okay, and also we have in the backup protection we have overcurrent and earth fault. In that we have HV backup and then we have LV backup. Okay, so for HV backup, I'll just zoom this. HV backup, we use low set setting as 120% of the HV full load current, and earth fault we use 30% of the CTR, and the ROT we keep as 500 milliseconds. Similarly for high set, we also use the high set overcurrent high set. That plug setting we keep as 80% of LV bus fault current, and earth fault high set we keep 60% of LV bus fault current, and high set delay we keep as 350 milliseconds. Okay, similarly we have LV backup. Backup also plug setting we keep 120% of LV full load current. Earth fault plug setting will be 30% and relay operating time of 350 milliseconds. Overcurrent high set we keep 60% of the LV bus fault current. Earth fault high set we keep 30% of LV bus fault current, and high set delay we keep as 250 milliseconds. Alright. Then we have the feeder protection, downstream feeder protection. For that we use non-directional overcurrent and earth fault relay. Alright. And the setting we keep it as, for low set overcurrent low set we keep it as 120% of CTR, and earth fault plug setting we keep it as 30% of CTR, and TMS time multiplier setting we keep it as minimum. Alright. For high set overcurrent high set plug setting should be greater than that of the LV backup overcurrent high set. Similarly, earth fault high set should be greater than LV overcurrent high set. Okay, so so in this way, whenever the high set operates, the high sets of the downstream feeder will be operate first before the LV backup, high set of the LV backup. All right. And okay, so if if any downstream feeder fault, for a downstream feeder fault, the feeder protection fails to operate, this protection fails to operate, then the LV backup will operate. All right, LV backup will operate in about 350 milliseconds. And if the LV backup fails to operate, in the LV backup also fails to operate, then HV backup will operate in 500 milliseconds. So the fault is sustained for this much long duration, so it's better that the feeder protection is operated by the downstream feeder protection itself. All right. Also one thing to note here is that if the differential protection fails to operate, that is HVCT to LVCT zone, if there is any fault in between the HVCT to LVCT, and if the differential protection fails to operate, then HV backup protection will operate. All right. Also one more thing, one more type of protection here is, one second. Okay, can you see it clearly now? Okay, I'll just zoom in a bit. All right. So thermal protection, we are talking about the thermal protection, that is the temperature rises of the oil, and the winding, the temperature rises, so that we need to keep in control. Due to loading conditions, the temperature may rise, we need to keep it in control. For that we use HVWTI and LVWTI, we combine together, and we use those for S1 switch is used for alarm at 85, it's set at 85 degrees Celsius. S2 switch, it has got switches, in the winding temperature indicator, that we use for alarm. S1 is for alarm, S2 is used for tripping. When it goes to it's set at 95 degrees Celsius, and temperature of the HV winding or the LV winding goes up to 95 degrees Celsius. Then we trip the transformer. Okay, and the S3 switch is used for turning on the fan on the auto mode. It is set at 60 degrees Celsius. Alright, switch S4 is kept as spare, or switch S3 can be used for fan auto group 1 and S4 for fan auto group 2. Or if there's a pump, then we can use it S4 for pump set at 70 degrees Celsius. Okay, alright, and then there is OTI. It has S1 alarm set at 80 degrees Celsius, and S2 switch is used for tripping set at 90 degrees Celsius. So in this way we try to study the transformer protection and downstream feeder protection in short. If you like the video, do subscribe to our channel. Also, we are very much active on the LinkedIn. To search us on the LinkedIn, just type my name Nitin N, and also type protection engineer, so that my profile will pop up in the top. Thank you so much. In the future we'll bring such more videos on transformer and lines and everything related to EHV power transmission system. Thank you so much.